As we continue our L.A.M.E.C.O.W discussion, we'll be moving on to the O and the W. Let's just recall, so far we've talked about L for latitude, A is for air pressure, M mountain barriers, E elevation, C continental location. Today we're moving on. W is for wind. We're going to talk about a couple different types of wind, local winds and global winds, and from there we'll eventually get to O is for oceans. But for now, winds are going to be our focus. Now, a couple things basic about wind we have to know before we can move on. We want to know what causes wind. Wind, of course, is the movement of molecules across the surface of the earth, and that is all happening because of differences within air pressure. Okay, of course, we have our two types of pressure. We have high air pressure and we have low air pressure. And the formation of those two different types of pressures and the balancing out, or the attempt to balance out, of those air pressures is really what causes wind and the motion of those molecules. Now, just a quick review on the right-hand side there. What causes that air pressure difference? The main thing that we discussed was temperature, and specifically uneven heating of the earth. Okay, so on the right-hand side, we just want to make a little note here that the air pressures are caused by uneven heating on the Earth's surface for a couple of reasons. We talked about the heating is uneven due to the tilt of the Earth, right? Different areas get more or less direct rays than others based on their location. We, of course, know the equator has the most direct rays. We also talked about different materials, heat and cool, like water versus land, or dark versus light. So all that uneven heating creates these little pockets of air that have different pressures. It's important to also keep in mind that elevation and humidity also affect the air pressure. When I have an increase or decrease in humidity, I'm going to notice an inverse relationship with air pressure. And that's what we talked about all last week with our A for L.A.M.E.C.O.W. Talking about if there's any increase in elevation, our air pressure must do the reverse and decrease, and vice versa. Another background piece of information we need is how are winds named. Winds are named by the direction they come from. Living in Minnesota here, we hear a lot about the polar vortex. Air coming from the poles, cold air coming into our area. So air or winds are named by the direction that they come from. So looking at this little weather vane here, we know the weather vane is showing us the wind direction. So if the wind is blowing this direction, it's coming from over here, we would then label this as a west wind. So again, winds are named by where they come from. Usually we see those directions in their name, north, south, east, west, but sometimes it can be a land breeze or an easterly wind, something like that. Okay? Now, as that air is moving around, we know it's always going to go from areas of high pressure to areas of low pressure. Air basically has a job to keep the atmosphere balanced. It's trying to take areas with extra air pressure and balance it out to areas with low air pressure. So we can see an example here on this diagram where we have this fire. Right? The fire, of course, is heating the air, causing that warm air to rise, making low pressure on this side of the room. Whereas on this side, I've got my cold air from being away from the fire. Cold air sinks, making high pressure. So I notice a draft in my house, or a little breeze indoors, because of the motion of that air from high to low pressure. A balloon is going to be a similar example, right? I blow up a balloon. The balloon is then full of air, high pressure zone. All those molecules are packed together. And when I release the nozzle, it's going to exit the balloon, pushing towards that low pressure area, making a breeze from high to low. So wind in the air the atmosphere, all of the earth is always trying to keep that balance from high to low pressure. Now we can see that information on a weather map like this one. This one has something called isobars on here. And it's basically like a weatherman's connect the dots. Okay? An isobar is connecting areas with equal air pressure. So as we look at this map here, we see these numbers, 1024, 1020, 1016, and it's got a line attached to it. So anything along this 1016 line has an air pressure of 1016. Anything along this line has an air pressure of 1024. So it is matching up areas of equal air pressure. Now what I notice is when I connect all those isobars together from different weather stations, what I end up with, seeing on the map, is areas of both the highest and lowest pressure standing out. So as we look around on this map here, looking for both the highest and the lowest air pressure, I should start to not only see the high and low numbers, but I should start to see the H and the L on the map. So if we zoom in on it a little bit here, my highest pressure, as I start to look over all the numbers, my highest pressure is here at 1028, and what do I notice on the weather map? But a nice blue H. And I'm looking for the lowest. That's going to be here, 996, right where the nice red L is. So a meteorologist who's drawing in these isobars, putting them in, they would then scan all these numbers and actually place the L and the H on there, showing the zones of the highest and lowest pressure. Now this is going to tell me a couple pieces of information about what's going on in this area. It's going to give me an idea of the direction the winds are moving. And it's also going to give me an indication of wind speed. Okay? When I'm looking at the spacing of the isobars, I'm getting a really good idea of the speed of the wind. And I'm not going to get an exact number, but I guess get a general sense. Are they moving fast or are they moving slow? In the case of isobars that are closely spaced, those are areas that tend to have the fastest wind speeds. So the closer the isobars are, the faster the air is moving. So if I look back at my diagram here, I've got a lot of isobars quite close together in this zone. That means a change in pressure very rapidly. That's going to give me a high wind speed. When I have isobars that are widely spaced, what I'm going to notice is that it's a weaker pressure or a weaker wind. So the widely spaced isobars give me a weak wind strength. So again, looking back at my map, when they are spread more further apart, I know it's a longer distance for that pressure to change, so it's a much slower wind speed. Whereas here, the closer they are together, these are going to be a much faster wind speed. So a little sample problem for you here. We can see two examples of isobars. I've got one set here, set CD, and I have another set of isobars here, set AB. I want to then figure out which one would have the greater wind velocity or the higher wind speed. Looking back at my notes, if I want the wind speed to be faster, I'm looking for isobars that are closer together. So if I'm looking at the bars that are closest, I'm going to choose AB because their bars are much closer together. Okay, so just to give you a little idea here, this is happening on a weather map, lots of different information. I've got the highs, I've got the lows, okay? I've got the isobars shown on here, and I can clearly see where the high and low pressure zones hit. I know what type of weather is associated then. I've got the high and dries, the low and cloudies, but I can also see where the winds are coming in. Right here I see Minnesota has a high wind, where kind of the central east coast down here by Florida would have a much lower wind for that day only. Right? These are things that change every hour, every minute. And so we might notice by the next day the high pressure has then moved a little bit further to the coast. Right? This storm would have reached us and probably passed on within the next 24 hours. So this is something that regularly changes as the air moves across the globe. So just a quick intro to wind, a couple things that we need to know before we really start talking about our major wind patterns.